Today we are going to be looking at the atomic structure of the atom. In other words, how to find the number of protons in an atom, how to find the number of electrons in an atom, and how to find the number of neutrons in an atom. In order to do this, you're going to have a copy of the periodic table. I'm going to show you how to use the key on the periodic table to show you what is inside of each block on the periodic table and how you use that to determine the number of protons, electrons, and neutrons. So what you see here is just the copy of the atom. It's important to note right off the bat that the atomic mass is what is represented by what is inside the nucleus of the atom only. So the atomic mass tells you what's inside the nucleus, and that includes the number of protons and neutrons, which you're going to have to calculate. Masses of atoms, we already talked about that yesterday, but it also includes quarks, which are smaller particles of matter that are inside the protons and neutrons of the atom. That is what makes up the protons and neutrons of the atoms, but we're really not going to be talking about that. So atomic mass is composed mostly of protons and neutrons inside the nucleus of an atom, and it's also called the mass number. So again, the atomic mass is what's inside the nucleus, and if you're looking at a key on the periodic table, which would each box on the periodic table looks like this, the atomic mass number is at the bottom of the box. And typically you round that atomic mass number, so 15.999 becomes 16. This number in the top of each box is your atomic number. This is your element symbol, and this is the element name. Now, if the element symbol has more than one letter, the first letter will always be capitalized and the second letter will not. So if you have an assignment where you have to write the element symbol and you write both letters, if there are two or more, capitalized, then it would be counted incorrectly, because these are the official symbols of each element, and the first letter is always capitalized, the second letter is lowercase. If you look over here, you can see that the atomic mass equals the number of protons and neutrons, because that is what is inside the nucleus. Okay, so again, this is the atomic number at the top of the box, the element symbol, the element name, and finally the atomic mass number, which we are going to round. So the atomic number is the number of protons in an atom. It also helps identify the atom, because all atoms have different atomic numbers. So therefore they have a different number of protons as well. The atomic number also tells you the number of electrons in an atom, and each atom has its own number of electrons too. So here's the way it works. This box represents the element hydrogen. The atomic number 1 is at the top of the box. That means that hydrogen has 1 proton and 1 electron. So the atomic number is equal to the number of protons and electrons. So if the atomic number of an atom is 5, that means it has 5 protons and 5 electrons. If the atomic number of an atom is 12, then that means it has 12 protons and 12 electrons. So let's look a little closer. There is a structure that you can use, or an acronym, my bad, that says 8-man. 8-man, sorry about that, I had a little dog barking here. So 8-man is the acronym that can be used to help you decide how many protons, electrons, and neutrons there are in an atom. So let's break it down. A in 8 stands for atomic number. P in ape stands for protons, and E in ape stands for electrons. M in man stands for mass number, A again stands for atomic number, and N in man stands for neutrons. So what we want to do right now is look at ape. So ape is a very simple process. Atomic number is equal to the positive protons and negative electrons. So here's some examples. If you've got carbon here and the atomic number is always written to the bottom left, then carbon's atomic number is 6. So that means that carbon has 6 protons and 6 electrons. Aluminum's atomic number is 13. So aluminum has 13 protons and 13 electrons. Boron's atomic number is 5. That means that it has 5 protons and 5 electrons. So ape is very easy. It's the atomic number is equal to protons and electrons. So all you have to do is find the atomic number for that element in the top of its box, and whatever that number is, the number of protons and electrons is equal to that. Okay, so again, how to read that key on the periodic table. Sometimes they look like this, but it's the same basic structure. This one has the element name first, the atomic number, the atomic symbol, and the atomic mass number. So the atomic number for this element is 42. So according to ape, the atomic number is equal to the number of protons and electrons. So that means it has 42 protons and 42 electrons. And again, the first letter is capitalized, the second letter is not capitalized. Now we're going to look at how to find the number of neutrons in an atom, and this is where the man portion of ape man comes in. So there goes my dog again. So the first thing that you're going to do is round the atomic mass number to the decimal. The second thing you're going to do, and that's mass number. The second thing you're going to do is subtract the atomic number from that rounded atomic mass number. And the reason that you do that is because the atomic mass tells you what's inside the nucleus, and the atomic number tells you the number of protons which are inside the nucleus. So if you have protons and neutrons inside the nucleus, you can look at the atomic number to tell you the number of protons, but then you have to subtract the atomic number, the number of protons, from the entire atomic mass number to get the number of neutrons. So let's look at this process a little bit differently. So now we are looking at man. So M again is for mass number, A is for the atomic number, and N is neutrons. And here's how you do it. It's very simple. You take the mass number in the bottom of the box, you round it, you subtract the atomic number, and that will give you the number of neutrons. So here's your examples. You've got carbon. The mass number is always written in the upper left. So the mass number for carbon is 12. The atomic number is 6. So if you want to find the number of neutrons, you just do man. Mass number 12 minus atomic number 6. You have 6 neutrons in carbon. If you're looking at aluminum, you have a mass number of 27, an atomic number of 13. So if you do man, mass number 27 minus atomic number of 13, you'll find that there are 14 neutrons inside the nucleus of a aluminum atom. So it's very simple for these particular elements. If you follow man, you can find the number of neutrons. So first is mass. So this would round to 1. Mass number minus the atomic number, 1 minus 1. There are 0 neutrons in a hydrogen atom. It has no neutrons inside its nucleus. Let's look at helium. Mass number, which is 4, minus the atomic number, which is 2, tells us that there are 2 neutrons inside a nucleus of helium. Now let's look at lithium. Lithium, the mass number rounds to 7, minus the atomic number 3 tells us that there are 4 neutrons inside of a lithium nucleus. Let's look at carbon, which we've already done, but this mass number rounds to 12 minus the atomic number 6. That lets us know that there are 6 neutrons inside of a carbon atom. Nitrogen, this mass number rounds to 14 minus the atomic number of 7. That lets us know that there are 7 neutrons inside a nucleus of nitrogen. And finally, oxygen, this mass number rounds to 16 minus the atomic number, which is 8. That lets us know that there are 8 neutrons inside of oxygen. So just one more time for review. Let's look at ape, which is atomic number is equal to protons and electrons. And then man, which is the mass number, minus the atomic number, will tell you the number of neutrons inside the nucleus. Again, if you go back to atomic mass, you're going to see that the mass tells you what is inside the nucleus of the atom, and you're pretty much given the number of protons, so you have to use man to calculate the number of neutrons.